Hi students, so now we will be solving this particular problem here in integration. The problem is that integration of 1 minus cos x divided by cos x into 1 plus cos x dx. Alright. Now in these kinds of problems, what you have to do is you have to add and subtract by a cos x so that you can reduce this entire function into something more simplified. So what we will be exactly doing here is I'll be adding a cos x and at the same time I'll be subtracting a cos x in order to ensure that my original function doesn't ruin. Alright, so when I take a plus cos x, I forcefully induce a term. Alright, I forcefully induce the term of plus cos x in the numerator. So as I said as I told this to you before also, that whenever I forcefully induce any function in the numerator, it is important for me to also nullify it so that the original function does not change. So when I add a cos x and subtract a cos x at the same time, then this entire thing becomes a 0. So ultimately we have nothing left but a 1 minus cos x in the numerator. But what is the reason behind me taking a plus cos x, behind me forcefully inducing a plus cos x? You will get to know it as we proceed ahead. Now this is 1 plus cos x, right? And here minus cos x is nothing but minus 2 cos x, because minus 1 and minus 1 is nothing but minus 2. And then I'll be separating the two parts, right? So I have a 1 plus cos x here in the numerator and a cos x into 1 plus cos of x in the denominator in one part, and in the second part here I'll be having a 2 cos x in the numerator, and in the denominator I'll be having a cos x 1 plus cos x into dx. Now what is my next thing that I have to focus on here is I can see that this particular thing gets cancelled with this, and this cos x gets cancelled with this cos x. So ultimately what I am left with is nothing but a 1 by cos x into dx minus of, I'll take the 2 outside of the integration since it's a constant, and in the denominator I'm left with a 1 plus cos x into dx. Now as while discussing about trigonometry earlier as well, I told you that 1 plus cos x is nothing but 2 cos square x by 2. Alright, these are the formulas that you will be finding in your 11th grade books, where you will see a chapter called submultiple angles in trigonometry. You will be coming across 1 plus cos x type formulas there itself. Alright, I can write 1 by cos x as sec x, which we know is nothing but a trigonometric identity, and I can replace this 1 plus cos x with nothing but 2 cos square x by 2, which we have already done earlier. And finally what we will be left with is nothing but integration of sec x, as we have already done this formula before. It is nothing but log of sec x plus tan x, right? This is x minus of 2. Now what will I did a mistake here. It's not 2 cos square x by 2, it's actually, I think it's it's 2 cos square x by 2 only. Yeah, it's okay. Yeah, so this is 2 only. I am doing a mistake again. So this is 2 only, and what is happening here is perhaps this 2 will cancel with this 2. Alright, so ultimately I'll be left with nothing but an integration of 1 by cos square x by 2 into dx. Now next it will be log of sec x plus tan x minus, as you know that I can write 1 by cos square theta as nothing but sec square theta, right? So this will be sec square x by 2 into dx. Now coming to the integration portion, this will be as it is, and here in the integration of sec square x by 2 into dx, what we will be getting is nothing but integration of sec squared theta, d theta is nothing but tan theta, right? So here we will be getting a tan of x by 2. Is it over yet? No, it is not. We have to have a half in the denominator. I already discussed about such things before, alright, because this is not just a mere sec square x. If it would just have been a sec square x, then we just have a coefficient of 1 here, right? So here when you do the integration of sec squared x dx, it is nothing but tan x plus c. But in place of x, if you have a half, like if you have x by 2, right, then in that case when you integrate, first it will be as normal as we know it, that it will be tan x by 2, alright, but the coefficient of half should come in the denominator. Always remember that, because you know a lot of students make these kinds of mistakes, alright, and we have a plus c. Also, I would recommend you that here I have done a slight possible mistake, you can say, because you know, you can do one thing, and that is when you do the integration, try to perform the entire integration in one line only. Like what I have done here is I have integrated this first part here, and then I have this integration sign again available here. What I mean to say is, if I am doing this integration thing, then I'll do that all together. I'll not do it like one part, I'll do the integration first and then I'll do the integration of this part here. Then what will happen is there will be a problem of placing constant of plus c. Alright, what I'm trying to say is, here also I'll write integration of sec x dx, alright, here also I will write integration of sec x dx, and then ultimately here in this particular step only, I'll integrate this sec x, which is nothing but log of sec x plus tan x. Alright, I'll integrate the entire expression in one step only. Alright, I'll not integrate one half part in one step and the other half part after 2 steps. What happens in that case is there is a problem in the placement of c. Okay, so in order to avoid any form of unnecessary confusion, I wanted to tell you that do the integration part entirely in one line only. Alright, then placing the c will not be a problem. Here if I integrated the first part here only, then the c, placement of c becomes an issue again, right? So in order to avoid such unnecessary confusions, even if you know that the integration of this thing will come in next step only, because we all know that integration of sec x is nothing but log of sec x plus tan x, even after knowing that, you cannot integrate it in the next step, because if you do that, there will be a problem in placing c. So in order to avoid such a problem, I want you to perform the integration in one single step. Alright, that is what I have done here, and this is the final answer. And I want you to do another problem by yourself as your assignment, you can say, and this is also a similar kind of problem. This is why I want you to practice it. Okay, the pattern is exactly the same, the only difference being that you have a sin x here instead of a cos x. Alright, else everything is the same, because if you look in this problem, we had cos x. In all the places of cos x have been replaced by a sin x. That's the only difference in this problem. Okay, what you have to do is you have to approach this problem in a similar way. Add sin x and subtract sin x in the numerator, and then make the necessary cancellation, and then come to a more simplified version and then simply integrate. It's a pretty kind of 2-3 step process. I have shown so many steps, but essentially because it's required in your board examinations. But in case you are preparing for joint and other examinations, This is a problem which you can actually complete in 1 or 2 steps only, okay? But I want you to break down all the steps, because considering you are a beginner, you need to understand things first instead of making all these assumptions, and instead of trying to directly apply stuffs and then trying to reimagine stuffs in your head. It becomes very confusing. All right, so I want you to solve this problem by yourself, and I'm telling you what your answer will be. So your answer will be nothing but log of mod cosec x minus cot x plus 2 tan of x by 4 minus x by 2, all right, plus c. This is x, okay? These two are x by 4 minus x by 2 plus c. So I basically want you to solve this problem. It might occur to you, the solution might make you feel that maybe it is a bit complicated, but trust me, it is not. But here there is a little trick that you have to use, and that is when you come into the middle of the problem, all right, after doing about 2-3 steps, then you'll realize that there is a slight sort of change that you have to do from sin x to cos x, all right, so that the application becomes much more easier for you. Now, okay, I'll be solving this problem in the next video for you, but as of now, I want you to solve this problem by yourself, all right. In case you cannot solve this particular problem given to you, I'd want you to actually comment and let me know. If you cannot solve this problem, I will solve it as well as explain it for you, okay? Till then, I want you to actually solve the problem by yourself. In case you cannot solve it, please let me know in the comments below, okay, that you are not able to solve the problem. And if you could solve this problem, very good. Then also let me know in the comment section that you have been able to solve this particular problem, okay? So if you really like my video, then please don't forget to like, share, subscribe, and hit the notification bell icon for more of such exciting content. All right, now we will proceed forward to our next problem.